This is the DeWys Manufacturing sorting machine senior project. We are team number 7, which consists of myself, Brendan Slocum, Brian Cowell, Christian Williams, and Trevor Bishop. DeWys Manufacturing offers complete metal solutions, including sheet metal fabrication, CNC machining, and powder coating, and they're located in Marne, Michigan. Some background information on the project. DeWys Manufacturing uses silicone caps and plugs to protect critical hardware during their powder coating process. These silicone caps and plugs are reused, but in order to reuse them, they must be cleaned of any excess powder coat using a ceramic abrasive media in a tumbling machine. Following the cleaning process, these parts are currently sorted by hand from the ceramic media and then sorted based on their part number into different bins to be reused again. DeWys Manufacturing has requested that an automated sorting machine be designed and built to sort silicone caps and plugs from the ceramic media and sort the caps and plugs into size ranges. Some key specifications on this project: the machine had to sort with a less than 5% error, sort with an accuracy of plus or minus 0.02 inches. It had to be semi-portable and on wheels, and had to fit within a 5-foot by 10-foot footprint. Our design consisted of 2 separate modules that use 2 different methods to sort. The first module, the fluid bath module, sorts by density, and it allows the silicone parts to be sorted from the abrasive media. The second module, the diverging rollers module, sorts by outermost diameter and allows the silicone parts to be sorted into bins by their size range. Here's a brief overview of the fluid bath module, which you can see highlighted blue. In the fluid bath module, a mixture of silicone and ceramic parts enter the first stage of sorting via a vibrating hopper. These parts are dropped into a tank with flowing water, and the ceramic parts, because they're more dense, they fall a lot quicker than the silicone parts, and they're collected in a custom basket we designed. The silicone parts flow with the current and are brought to the end of the tank, where they flow over a ramp and over a piece of mesh where the water is sorted from the silicone parts. The water then goes back into our reservoir, where it can be reused again. Some key features and components on the fluid bath module include the pump, which actually creates the flow of water through the tank. We have a filter to ensure that the pump doesn't get clogged with any debris and to ensure that the water is clean. We also have a motorized ball valve, which is actually between the pump and the fluid bath tank. This allows the piping to be cut off when the machine is off so that the water from the tank doesn't drain down. We also have a float sensor on the reservoir to indicate to the operators when the water level is getting low. We also have our ceramic basket, which is a custom basket we designed to pull the ceramic pieces from the fluid bath tank. And then we have our reservoir and drain and tank drain spigots. These allow water to be drained from the reservoir and the fluid bath tank to make moving the machine a little bit easier. And then we have an exit grate, which has the piece of mesh over it so that the silicone parts can be sorted away from the water and the water can be reused. Here's a brief overview of the diverging rollers module, which can be seen highlighted in blue in this picture. Silicone parts are also fed into this stage using a vibrating hopper. The diverging rollers module consists of 2 rollers that are angled downward and diverge away from each other. These rollers rotate in opposite directions in an upward motion, and then once silicone parts reach the rollers, they will travel between the gap of the rollers until the gap is too big for the part, where it falls down into a bin below to be collected. Some key components on the diverging rollers module are the DC motor, which actually turns the rollers. We have 2 safety limit switches, which allow the machine to be turned off when our doors are opened to prevent operator injury. And then we also have side guards on the rollers, which keep the parts from rolling off of the rollers. And then we also have a plexiglass door and top so that the operator can see the machine working. Our machine's electrical system is set up so that each of the modules can be started and operated separately. However, the emergency stops allow both the modules to be stopped simultaneously. We also have a 32-pin connector, which allows the machines to be disconnected so that they're easier to move around. And then we also have a safety relay module that has dual channel monitoring to ensure that all of our safety devices work as they should. Here's a brief summary of our mechanical build, and on the right you can see where we were just a few weeks ago. We started our mechanical build by assembling our extruded aluminum 80/20 frames. Following this, we mounted all of our sheet metal plate, which allows all of our other components to be mounted. Following this, we mounted our rollers on the diverging rollers module, and then on the fluid bath module, we installed the tank and all of the hardware that goes with that, and then we attached the tank to the pump. Here are a couple photos we took during our mechanical build. On the left, you can see our diverging rollers, and then on the right, you can see our pump and some of our plumbing going up to where the tank will be. Here's a brief summary on our electrical build. The first thing we did was we set up for a bench test with all of our devices and spent some time troubleshooting. This was just to ensure that all of our devices worked as we had planned. The next thing we did was we installed all of our components inside the enclosures, and we did some preliminary installing of the devices on the modules as we could. Following this, we mounted all of the enclosures and then wired our 32-pin connector, which allows the machines to be disconnected from one another. And then we did a secondary stage of testing with everything mounted. And then lastly, we ran our wires through conduit to ensure that none of our wires would be exposed to the elements. Here are some photos of our electrical build. On the photo on the left, you can see that was when we first installed our back panel into the enclosure. On the second photo, you can see our main enclosure and our diverging rollers control panel, which features an emergency stop button, a safety relay reset button, and a DC motor controller to control the speed of our rollers. And then on the third picture, we have our breakout box, which is mounted on the fluid bath module, and then we have our fluid bath module control panel. And as well, you can see our 32-pin connector and our conduit that runs to our main enclosure. Currently, we have completed construction on our original design, and we have tested both the modules preliminarily. From these tests, we have determined that slight modifications needed to be done on both modules. Following completing these modifications, we will be doing full testing on the machine. Some challenges we had to overcome on this project. Electrical design was particularly difficult for us. We have 4 mechanical engineers. Along with this, we had to deal with a lot of long lead times, so we made do with what we could and found replacement parts for things that we could. Other challenges were mounting the diverging rollers and aligning them correctly, and also mating the fluid bath components to ensure that there weren't any leaks in our system. Following completing our modifications, we will be retesting each module separately. And then once we've determined that's successful, we will be testing both modules simultaneously, as it will be working at DeWys Manufacturing. Following this, we will do any fine-tuning that we need to for each module. For the roller module, that would be changing the angle of the rollers, changing the speed of the rollers, and for the fluid bath, that would be changing the flow rate going into the fluid bath tank.